Dear students, in the previous video, you understood Bohr's postulates and its limitations. There we discussed that Bohr's theory violates Heisenberg uncertainty principle, it violates dual nature of matter, it violates Zeeman effect, Stark effects. It is applicable only for monoelectron system. Okay. So now let us see how it violates. In order to understand the violation of Heisenberg uncertainty principle and dual nature of matter, first you must know the dual nature of matter and radiation. That means dual nature. Usually a matter exhibits both electron and particle nature. Particle nature and wave nature. That means you know how wave nature means it has frequency, wavelength, intensity. That means wave-like motion. You just observe the diagram here. So this is a wave. Okay, if this is a circular motion, okay, this is a wave motion. Wave motion. And usually particle. So particle means what? It has linear motion, linear movement. There we cannot observe wave motion. Okay, particle is different and wave is different. And some of the properties, the optical properties like diffraction, interference, can be explained by considering light as a wave. But if you consider some of the properties like photoelectric effect, blackbody radiation, there you cannot explain the properties if you consider the light as a wave. But if you consider light as a particle, so what happens in photoelectric effect when light incident on a substance, okay, substance or metal surface, so electrons are come out from that, electrons are ejected from that, okay, that is one particle incident on other, so the particles are coming out. So this is particle nature. So if you light is interact with the metal surface, so particles are comes out, particle nature. So these effects like photoelectric effect and blackbody radiation can be explained with the help of by considering light as a particle. Here we observed two different situations. That is, some of the properties we explained by considering light as a wave, and some of the properties we explained by considering light as a particle. But the de Broglie says that these light and matter act as both wave and particle. They possess both wave nature and particle nature. That is according to him. According to him, a particle from all start electrons, protons, atoms, molecules, a piece of chalk, iron ball. So all are act as a wave as well as particle. So he concluded that so both matter and radiation, they possess both the nature. That means so both act as particle as well as wave. This nature of a substance, this nature of radiation and matter, it is called as dual nature. That means both possess particle nature as well as wave nature. So this phenomena is called as dual nature of matter. So de Broglie explained dual nature of matter and he tried to give the relationship between wave nature and particle nature of matter through the equation. It is called as de Broglie equation. So let us see the equation here. So we know that Einstein energy mass equation, E is equal to mc square. That is, if you consider a wave, radiation or light as a particle, then the energy of that radiation is nothing but, so E is equal to, so mc square. That is, m is a mass and c is its velocity. The product of mass into square of velocity is nothing but energy. Okay, and we also know that from the Planck's equation, that is quantum theory, so the energy of wave is equal to E is equal to h into nu. That is the energy of radiation, it is directly proportional to the energy of radiation, it is directly proportional to frequency. Then this proportionality is removed by introducing a constant called Planck's constant. So E is equal to h nu. So dear student, here we have a two equations. So one equation, it is the energy of a light by considering as a particle, and this is the energy by considering wave. But de Broglie combined both the equations. So on equating equation, because a same substance exhibit both the property. If same substance exhibit both the property, the energy must be equal. So then taking the equation Einstein mass energy equation and Planck's equation, and so equating equation 1 and 2, so it gives mc square is equal to h nu. And we know that so nu is equal to c by lambda, that is frequency is equal to velocity of light divided by wavelength. And if you substitute the value, if you substitute the value of frequency in the equation 3, okay dear students, so while I am explaining derivation, you please take a pen and paper. So you goes on writing, you goes on simplifying the equation, then only you can understand the equation. Here, so we know that mc square is equal to h nu. On equating 1 and 2, we are going to get mc square is equal to h nu. But nu is equal to c by lambda. Substitute the value of nu in the above equation. So we are going to get mv square divided by hv lambda. Here we replaces v by c. Here this is a frequency. This is called as actually nu. This is frequency, but this is not frequency. This is v here in this equation. So v is nothing but velocity. Okay, because c is nothing but indicates velocity of light. But here we are discussing both particle nature and wave nature. So that's why in general we are considering velocity of an object by putting the symbol v. That's why here instead of mc we are going to take mv square is equal to, so h nu by lambda. Here nu is equal to c by lambda. Here instead of c we have take v by lambda. Here v is nothing but, so this is nu. Actually this is nu. This is nu is the frequency, and c by lambda. So instead of c, here c is equal to velocity of light. I took v by lambda. Then mv square is equal to h v divided by lambda. Here v get cancelled. Then you will get lambda. Then after simplifying this equation, then you are going to get mv is equal to h divided by lambda. Then if you simplify this equation, so you are going to get lambda is equal to h divided by mv. So keep lambda on the LHS, and so then lambda is equal to h by mv. Then we know that the mass, the product of mass into velocity is equal to momentum. So it is represented by p. Then lambda is equal to h by p. So this equation is called as de Broglie equation, and here lambda wavelength is called as de Broglie wavelength or de Broglie wavelength. So the derivation of de Broglie equation is very simple. Dear students, first consider Einstein mass energy equation is equal to mc square, and then consider Max Planck's equation, then equate both the equation, then replace velocity of light c by v, then you are going to get the Neve equation. Then if you simplify the Neve equation, you are going to get h is equal to h by p. That means the velocity, the wavelength of any substance is equal to Planck's constant divided by its momentum. Dear student, the significant this equation is highly significant. So this is significant only for microscopic particle. So even the macroscopic particles are also a wavelength, but the wavelength is very small. That's why we are going to neglect it. And if you calculate the wavelength for microscopic particles like electrons, protons, neutron, so the value is considerable. It is comes in the range of nanometer. But if you calculate this wavelength for macroscopic particle, it is too small. That's why so this equation is applicable for microscopic particles.